Again, welcome to Innovative Digital Twin Workflows using ArcGIS webinar. Today's key takeaways for the webinar will be following. What is a digital twin, why a digital twin is there, and we will be also looking into different maturity levels of a digital twin, where we will be seeing different workflows for planning, operation management, situation awareness, etc. Now, talking about our first point, why digital twins are required. A digital twin is coming into the picture when our world is transforming and the way we look into the systems are changing. We all deal with a GIS-enabled landscape information model, building information model, network information model, and city information models. When we abstract all these things together, we are able to create a GIS-based digital twin. A GIS digital twin enable us to have all these things together and model things on top of this. This will enhance our visualizations and analytics and the way we deal with the systems. Now the question is, what is a digital twin? A digital twin can be a system which can represent the system as of it is now, it is in the future, or what it was in the past. So the records of the things which is coming to the system is enabling us to do all these different levels. Now, how we will be creating a digital twin? There's a common misconception we follow that a digital twin is just a 3D representation of the real world. But it is on top of that, the real world models coming with the data integration, and we will be doing real-time data on top of this. And on this base, we will be doing visualization and analytics, which will be enabling us to do scenario-based management and planning. So the concept of digital twin is all these things coming together, which is enabling us to do better planning, better operational management, and many more things. Now moving ahead, how ArcGIS is fueling digital twins. ArcGIS comes with a very strong 3D base. It is enabling us to do our environment modeling, network modeling, design construction modeling, planning, and operations. And on top of this, we have open data API integrations available. We can integrate real-time data, and the core and basic analytics of ArcGIS add a lot of values. And together, all these things help us to create our 3D system of records. And this 3D system of records act as our foundation for the digital twin. And moving ahead, when we work with a digital twin is enabled at various levels. It starts as a descriptive digital twin and it matures to an informative twin where we integrate more data, connect different data environments, IoT sensors, and moving ahead, we can do predictions with this digital twin with enabling AI/ML. And when we combine all these things together with scenario-based modeling and planning, we will be having a comprehensive digital twin. And at the end, it is moving towards an autonomous digital twin, where the system can self-learn based on all the previous inputs which we give. And with very minimal human intervention, we can have the decisions made on the digital twin. Now, talking about the very first stage of a digital twin, which is the descriptive digital twin. Here, we will be creating a very minimal part of the digital twin where the basic models and everything will be there, where we can represent the real world assets with a GIS context. And to enable this, ArcGIS is having various systems in place. So when we start with the digital twin, the first thing what we do is a data acquisition. And there we can use ArcGIS Reality Engine to process this drawn data, and it will be giving us various inputs for our next stage, where we can utilize ArcGIS Pro, GOI, AML to detect our assets which are needed, and followed by utilizing ArcGIS City Engine or any other 3D model generator to create level of detailings. And once all these things are done, we can take this into ArcGIS Enterprise to have our stakeholder engagements and to build different levels of front-end applications. Now, talking about the ArcGIS reality mapping, this acts as a very basic foundation for digital twin across ArcGIS because it is very important to have with us the basic 3D models and everything which is representing real world as it is. So ArcGIS reality mapping supports us to ingest various type of data, be it drone, aerial, or satellite. And these data, once ingested, the powerful reality engine will help us to directly produce various outputs, be it 3D mesh, true ortho, surface model, point cloud, or any other. And once we have this foundational content ready, we can utilize this to do different analysis, extract information from it, or to build 3D GIS models. So this base will be helping us to do our further analysis, and that's how it acts as a foundation for our digital twin. Now let us see a demonstration of how I was able to utilize these things and create a descriptive digital twin for Kerala. Now, Kerala is actually a semi-urban rural area which is located in Delhi. So that is also a concept we follow, that the digital twins are only for urban areas. But here we are looking into a different perspective, where the village of Kerala we are representing through a digital twin. Here I am having the true ortho obtained using the reality engine from the drone data. And from this true ortho, now I am going to utilize GIS models to take the building footprints, and also from base map I am detecting the building footprints here. And I also have some other assets like trees also detected here. Now once I have these detected building footprints, I'm going to utilize ArcGIS city engine to model level of detailings. And when we talk about city engine is coming with a very unique property, which is called CGA, or computer generated architecture. So you can see when you open City Engine, you have a different set of CGS inbuilt available. Either you can directly utilize here these things here, like I have used, or you can have this entire code with you and develop your own CGA models according to your geographical area. Now, another catchy point is sometimes you might have all this foundational data ready with us, but sometimes we are having a very basic thing. Okay, this is the area where I want to build my digital twin. In that case, also City Engine is coming to rescue for us. Here we are having the get map data option where you can search for your extent. And once you lock your extent, you can have different base maps available here, and it is enabling you to take all this data for your digital twin foundational creation. You will be getting a base map with high resolution SD world elevation, and also you can have OpenStreet data downloaded along with this, which can be converted to network models and building footprint models. So I have already taken some of this data here, like street network for my area. And also I have built using CGA my basic level of detailing one for the building footprints. Now, once these building footprints and all the models are ready, I can take this into my other system of records by simply exporting this. So City Engine is also giving me various level of exporting option. If I am continuing with S3 ecosystem, I can either take it as a file GDB or same layer package. But sometimes we have to take this to any other external system. So those options are also very much available. So I have taken all this information as a scene layer package to my ArcGIS Pro. And now I have given some modification to the building facades, and all the trees are animated using the inbuilt ArcGIS symbologies and water, everything. So now you can see I was able to quickly create a descriptive digital twin using ArcGIS Pro and ArcGIS City Engine, where I can see the real world assets and all. And now here we are having LOD level 1. Now to LOD level 1 and 2. Now to have a level of detailing 3, I'm also integrating the mesh which was generated using ArcGIS Reality Engine. And you can see how beautifully this mesh is being rendered, and I can even read the boards and everything from that area. So the Reality Engine processed 5-angle drone images are enabling with me this, and I am able to quickly create a digital twin, descriptive digital twin from a level of detailing 1, 2, and 3 with this. So now let us see what is the next stage we have to do. So we have seen the descriptive part of the digital twin. Now the next level of maturity is for the digital twin is the informative part. In the informative part, we are going to connect more data and also to have a situation awareness with real-time data. For this, we are going to use either ArcGIS Geo Event Server or ArcGIS Velocity we can utilize to connect our real-time information. These things are going to help us to integrate and ingest data, which we can utilize for our further visualization analysis. And based on this, we can create alerts, data management, and many other things. This can be utilized with this in the following manner. We can take different feeds coming from the ground, be it a IoT sensor, SCADA, or any mobile application, which can be integrated with our existing data sources. And we can utilize that for analysis, various level of attribute mapping and everything. And once those things are done with GIS-enabled or Velocity, we can utilize that for visualization, notification, or any other dashboard or web application support. So let us see a quick demonstration of the same here. So when we are working with this, so starting with the informative twin, I am first adding some other information here before the real time. So here I am having a building information model integrated to my digital twin, which is basically a coming from the AutoCAD Revit model. And these can be actually directly ingested into ArcGIS Pro by default. ArcGIS Pro support these models here. Now, to make my informative digital twin more data centric, I'm adding some point of interest here. And also I'm ingesting some building informations to this. So these things are some of the limited demonstration part, but you can integrate any other database, any other relevant things associated to your digital twin for this data integration. So here you can see the first level of my informative twin is getting ready here, where I have my point of interest. And now my level of detailing 3, the LOD3 models are having information embedded to it. I can see what is the type of the building, how many number of floors are there, and many other information. And once these things are done, I can simply take this information into my ArcGIS Enterprise. Here I have published all this into my ArcGIS Enterprise, and you can see how beautifully I can take all these things on the web level also. So in the web map also, I am able to have all this information readily available. And now as we are having our static information integrated, now it's time to have the real-time information also integrated to this. So here for the demonstration purpose, I'm going to utilize the I'm going to utilize a GeoEvent server here. So here in my GeoEvent server manager, you can see we are having different level of services here. So the base data for the simulation I'm going to utilize is the CSV, which is for the air quality information. And I'm simulating this using the default GeoEvent simulator, which is available. Here you can see once I upload my folder, I can have different controls available. I can simulate the data in various levels, like the number of events and how much time I want to simulate it. And even if I want to convert the current data and time, all these options I'm getting. And when we utilize the GeoEvent server or Velocity, the advantage we are getting, without coding, we can integrate multiple type of data set. If you are having an API in HTTP, TCP, UDP, or any other format, you can integrate this data with few configurations. So here I have already integrated my simulated information into this service, where I am having a TCP input, and it is mapped into a feature layer here. Now, as it is mapped into this feature layer, you can see how my data is coming into picture and the rates, how it is, and all these things you can customize based on your requirement. And now, as we are simulating this data here, let us see how it is going to help to have a situational awareness. So we saw that we are having our web map here. Now I have created a dashboard utilizing this digital twin web map, and you can see how beautifully the real-time data is getting integrated to the dashboard. We are able to see the situation of air quality in the various levels of Kerala. You can see how the data is getting ingested on the real time here, and how we are able to monitor the air quality index here. So in this manner, various departments or operational teams can create their digital twins and integrate the real-time data to that to have different level of monitoring or operational dashboards, where they will be able to do all these activities and to understand what is the situation on the ground. And that's how we can render a informative digital twin. Now, the most important part or the exciting part of a digital twin, the predictive digital twin. So to have a predictive digital twin, we are utilizing the GOI capability. We all know about the GOI, where the artificial intelligence, machine learning, deep learning is combined with spatial analysis, GIS, and which can be utilized for various things. And when we do a predictive digital twin, we can either use the core analysis capabilities of ArcGIS like spatial analysis, geostatistical analysis, network analysis, and also on top, we can either use the GOI vector tabular analysis or imagery remote sensing based detection. And these things will be going to enhance your workflow and reduce the manual intervention which you require to do this workflow. And also this will be helping us to do various levels of the digital twin. So let us see how we can utilize a predictive digital twin for a sustainable development. So here you can see I have my digital twin ready here. Now I'm going to utilize a core capability of ArcGIS or using spatial analysis, raster solar radiation prediction I am going to use. And for that, I have already utilized the DSM, which was generated by the reality engine. And to that, we can see here, we can mention the start date, which we require, and end date. We can have the time intervals and all these details we can mention and customize these things. So I have already done this for Kerala for this particular area. And this is helping me to predict the solar radiation for the year 2025. So in the first level, we are seeing the solar radiation predicted for the last week of January. And now this sort of information, how it is actually helpful. So let us take a scenario where a department or a utility agency wants to roll out a solar panel adoption program. Now they can utilize these sort of predictions to understand which all buildings are getting the maximum solar radiation. So in Delhi, we know at this point of time, the solar radiation is pretty much less. So let us take an example of a different month. For example, in the June. Now we can see that the things are getting changed. In June, we are having a very good solar potential over this building. Now, this information is helping us to understand the buildings where we can roll out the plan, and also the over the month, over the week analysis, which will be giving the information when there can be a surplus production of electricity also. And this surplus production of electricity, the citizen can sell back to these agencies, which is beneficial for them. And also this will be helping us to have a sustainable ecosystem. And in this way, you can utilize your digital twin to enable sustainability. And this was just one another example, and you can have different level of predictions and different level of models, which we can utilize for a better future creation. And now going back to the next level of digital twin. Yeah. The next level is the comprehensive digital twin. When we are talking about the comprehensive digital twin, we saw the levels, how a descriptive digital twin was created, and how we created it as an informative digital twin by integrating more information, and how we were able to predict on top of this digital twin. Now, when we talk about a comprehensive digital twin, all these things also comes to picture along with scenario-based modeling and planning. And there we can integrate more information like regional information, city information. And when we go for scenario-based modeling, it is also important for us to integrate the planning, regulatory norms, and many other things. And at this stage, we can also manage the project life cycle with building information model and all these things. And when we talk about all these things as a whole, this entire workflow is GIS enabled by ArcGIS. For the early stage, like the planning guideline integration, the system of record, in those stages, we can utilize ArcGIS Urban, ArcGIS City Engine to do all this modeling. And once the modeling and planning is done, when we start for the construction part, there we can utilize ArcGIS GeoBIM, where we can integrate the engineering part. And followed by when we go for the operational management, you can utilize all the enterprise enabled workflows and ArcGIS Indoor for a better comprehensive digital twin. Now let us take a look into a demonstration how we can actually utilize these tools to implement a planning digital twin. So here I am having my ArcGIS Urban ready here with the ingested data from Kerala. So first view which you are seeing is a 2D perspective of how these data sets are ingested. But when we go for a digital twin based planning, it is important to have a 3D perspective. And that's where ArcGIS Urban is enabling us to do the planning on 3D. And when we talk about the planning, it is, as we already discussed, it is very important to have all the rules and norms, regulations in place. So when we start with the ArcGIS urban model, we can have a system of record generated in place. So here in my system of record, you can see I can have all this information. So as the very basic information, I have ingested the uh, master plan details from DDA here, where what it can be a residential zone and what can be the parameters allowed for the residential zone, like that various zones which are allowed by DDA and the parameters are already fed here. Now, utilizing these parameters, only the planner can build things under this area. So in this way, we can restrict the planning based on the norms which are allowed by the respective agencies. So now once all these systems are in place, I can, as a planner, now I can just start by my 3D planning. Here I am having plans as well as projects. So plans actually stand for our long-term developments and projects are basically the short-term things which we can complete in 5 years or so. So let us take a look into one of the plans, which is the residential plan here. Yes. So when we are utilizing ArcGIS Urban is enabling us in various ways. It is not just about 3D planning, it also about the scenario management. Here you can see that I am having a scenario one created for the uh, enhancement of this area. And sometimes when we work, it is not just like, okay, I am completely sure that this is how I want to redevelop this area, but you might be going through different iterations. So that's where we can have different scenarios created based on all these norms. And as a very important thing, when we do these scenarios and all those things, it is also important to understand what are the outcome of this scenario. So ArcGIS Urban is also giving us that option with a dashboard. We can see how these developments are going to attribute in the future. What is the number of population it is going to serve, and number of household it is going to create, jobs, and different aspects which is required for planning, we can understand with ArcGIS Urban. And the best part is these things are not it is like these things are not auto generated. These things are under your control. You can customize the statistical equation based on your geographical area, your norms, like what is the occupancy for a building. All this information you can manipulate by yourself, and this, based on your statistical equation, it is going to give you the dashboard and the indicators. And utilizing these indicators, now I will be able to understand what is the internal water usage, what are the daily trips taken, and comparing this between the scenarios will also give me the understanding of which is going to be the best development model, going to generate more number of jobs, or which is the one which is going to be the best sustainable development model, and more things. And also when we do such things, it is also important to take the inputs from stakeholders and after a stage from the citizen feedback also. And to enable this sort of collaboration, ArcGIS Urban is also giving me an option for opening my plans for discussion. And when we open the plan for discussion, the people who are having the privilege, for example, I have currently opened it for the internal team only, where my internal team can give me feedbacks, how I can improve my planning. So they can actually pinpoint to a location and give their inputs for that area. Can we increase the number of floors or any other inputs which they want to give? And once we do all these incorporations, we can open this for citizens as well. And the best part is when we open these things for the feedbacks, we can also incorporate these feedbacks on the fly. For example, if I am getting a feedback like they want to change the type of for this area, I can modify that also. And the best part is you can do these things very quickly without recreating all the things, we can do these changes incorporated. Now, once we do and finalize a plan, it is important to visualize it in the best possible way, what it is going to bring in the future. So that is where the integration of ArcGIS Urban with City Engine is very important. So ArcGIS Urban and City Engine integration enables us to integrate whatever which we created there. We can take that into a City Engine. So you can see here the ArcGIS Urban icon here. So just by clicking that, I will be able to open my ArcGIS urban models here. You can see my urban models will be loading here. And once it is loaded, I can open the various scenarios from there. And the City Engine capabilities which we saw, we can utilize those capabilities on top of these ArcGIS urban models and on the scenarios. And once I am done with the modeling of the scenario with my CGA, the facades, any other green area or any other things, I can simply push this back to the ArcGIS Urban. Or I can save, or I can take this as a scenario also. So these different options we get with the integration of ArcGIS Urban and City Engine, where ArcGIS Urban gave us a schematic representation with indicators and all the details. And once it is finalized, we can build the realistic facades with ArcGIS City Engine, and we can push that back to ArcGIS Urban. Now let us see how it is coming back to ArcGIS Urban here, the changes which I have made. So you can see as a final scenario, I have taken the context which was generated with ArcGIS Urban and City Engine. And this is going to enable my stakeholders to understand the planning better. Because when we talk about the stakeholders, for them, it is also important how good the redevelopment is going to look like also. They might not be a GIS or technical person. For them, the facades are important. How the greenery is going to look like, all these things are important, and for them this realistic representation is going to help a lot, and they can also comment back if whether they want any changes and all those things. And also ArcGIS Urban is coming with different level of analysis tool where we can measure, we can slice, or we can see the view shed and many other things from the areas. So these things are also going to help us to analyze our development and planning with a digital twin perspective, and to get the results, and also to predict the outcome based on different scenarios and manage our planning in a better way. And I believe the urban planners and township developers joined in this webinar can definitely use this tool to ease their workflows. Now let us go back to our presentation. Now the next step, once we have done our planning, now it's the time for implementing the planned things. So in our areas where we have planned some buildings, now it is time to integrate the building information model. And when we talk about a building information model, the first thing which comes to our mind is the AutoCAD or a Autodesk view. And that's where actually the engineers do their basic parts where they construct the model of the building and all. But when we see all these things in an Autodesk view, what you can see here, we can see some things are lacking. I don't know where exactly it is located and how it is going to interact with the environment. But I get a lot of another engineering tool using which I can interact with this model, right? Now, when we take a look into the same with a GIS integration, that's where we are going to get the best of both worlds, you can see. So the integration and the hand-holding with SC and Autodesk is giving us with the result of ArcGIS GeoBeam. So here you can see in my screen that my model is geolocated. I know where exactly it is going to be built and what is the environment it is going to react with. And also it is giving me a holistic view of all the details which is coming from the engineering side, like the issues and the details of each and every object in these assets, with all the things coming and loaded from engineers. And the best part, as a decision maker, I can also see from a single window what is the Autodesk level of view. By just simply clicking, now you can see I am able to see the Autodesk level of view, and also I'm getting those tools which was available in Autodesk. So as a decision maker, I can interact with all these things with a GIS enabled capabilities. And also I'm having a quick dashboard where I can monitor the issues with this particular construction, what are the level of issues, and many other things. And when we take this into GIS, it is also giving us the capabilities to understand how it is going to behave with the environments. So here you can see how my building is interacting with sunlight. I can do line of sight. I can take different measurements of these things. And I can also understand the shadow cast here. So this shadow cast analysis will be able to help me to understand how the shadow is falling on the other important assets or environment and many other things. And when we do such analysis, we also identify some issues which can be arising later after construction. And doing this analysis will help me to resolve this issue in the very beginning of the designing state. And the best part is I can locate this issue from ArcGIS GeoBeam itself, and I am getting all those Autodesk fields here where I can fill what is the issue is about, type, status, title, date, and all those things. And once I create this issue, it will be going back to the Autodesk 360 place itself, and where the engineers can see the GIS issue I have logged, and they can take actions to that. And once they change those actions there, it is going to sync back to me. So in this way, ArcGIS GeoBeam is giving us the holistic way to approach our construction management, where we can have the engineering things in place with the GIS intelligence, and the location intelligence is going to give us the upper hand of GIS based analysis, where we will be able to identify many things like if the FAR is correct or the shadow is falling on wrong place or not. All these things we will be able to understand, and we can locate this issue early as possible, even before the construction, and that we can take actions accordingly. And these things will be helping us to reduce the cost of our construction when we know the things beforehand. And that's how ArcGIS GeoBeam is going to help us to better our construction management. Now, as we have our planning and the construction stage is done, now the next part is to do operational analysis on this thing. So let us take a look into another demonstration where we can do the operational management utilizing digital twin. So as we saw the planning and construction is done, let us see how the operational management can be done with ArcGIS. So here I'm having a warehouse management system experience builder. So in this dashboard, you can see I'm able to see all my warehouses located in pan-India level with various indicators, how the utilization is, what are the total number of warehouse, the capacity, and many other things. Now, when I'm going to take a look into this operational efficiency, I need to further drill down at various levels. So suppose I want to see the details just in Delhi, I can drill down to that locality. And in Delhi also, if I want to see about a specific warehouse, for example, as we are talking about the warehouse in Kerala, we can also check about that. So we can select any particular warehouse, and the informations will be helping us to drill down to that particular warehouse, and also I can get a operational view of this. And it is also important for us to have a facility level understanding when we go up about operational management. So here you can see my 3D integration is already done into my dashboard, and I can see my warehouse in the real time, how it is here. And also I can see how the utilization is done by allocated various companies, and what is the type of utilization, and I can switch between my facilities and many other things. And when we integrate our this informations to GIS, we also get the option to do various analysis. Now, when we do a warehouse operational management, it is important for us to find the closest facilities, plan the route for the trucks to travel, and calculate the travel cost time and many other things. So when we integrate the GIS, we are also getting this sort of analysis also, which will ease our workflow. And also we can slice into the warehouse and we can see what are the different levels and how these things are occupied and many other things. And in this way, when we do the facility view and management, the next level where we can drill down is the asset maintenance. And for that also we can do different level of workflows. Here you can see my total number of active assets and what are the jobs under those assets. And when we want to do the asset management, there might be a inspection which is going on and you have multiple other jobs. So you can see all the jobs which are assigned to different people and the asset related to that. And also you might be needed to do a new asset maintenance. So you can also assign that asset from here itself. So if I want to do a job assignment, I can simply do that also from this single dashboard itself. I can select the asset job category, what maintenance is need to be done, what is the priority level, and all those things I can select and I can assign that to a particular person. And if I want to attach something which is relevant to that person, I can do that also. And in this way, we will be able to do a overall operational management integrated with digital twin by enabling GIS to it. And it is also important, once we have all this information, we will be also monitoring how the things are going. And that is where the immersive experience is coming into picture. So here I have a 360 VR experience generated for my warehouse. So I can inspect the warehouse from various perspectives here. I can switch between the different views. I can check how the interiors things are going on and how much occupancy is happening and how the racks are occupied. So you can see the green shows the racks are occupied, the empty spaces, and all these things we can have an immersive experience. And when we go for stakeholder engagement, this immersive experience are very important. When they want to rent out, they can see how the warehouse is situated and how the security, how occupied it is, and all those things they can see, and then they can opt for the warehouse. And in this way, ArcGIS enable us to have a best operational efficiency with different level of engagement, operational workflow management, as well as stakeholder engagement. And I believe these things can be actually utilized by different authorities joined here. And now let us take a look into how we came from descriptive digital twin, we saw informative twin, then predictive and comprehensive twin. Now, as we discussed, the last part is autonomous digital twin, where there will be a minimal human intervention which will be needed, where the operations will be happening autonomously. So all these steps which we saw will be attributing to this autonomous twin, and the new enhancements coming in ArcGIS like AI assistant and all these things are going to help us to do so. And most importantly, the integration of ArcGIS enabling the AAML integration is going to help us to build a better autonomous digital twin and to enable us to have a self-learning decision-making system. I believe I was able to take you through the different levels of digital twin, and also we were able to understand how we can create different workflows. I think it will be helpful for everyone to implement digital twin in their day-to-day workflow, be it a government authority or a operational manager and everyone. And thank you everyone for joining the webinar. Now let's